Hey guys, I'm going to talk about the discriminant, which is actually just a sneaky little snippet of the quadratic formula, and it helps us find out about the roots of a quadratic without all the effort of going and finding them. Let's do this. Vocab. The quadratic, expressed as a y-equals equation, looks like a parabola. It's part of the polynomial family. The roots of the parabola, when we talk about roots of any equation, we're talking about the x-intercepts or the zeros. That's all the same thing. The reason we call them zeros is because they'll occur when y equals 0. The quadratic formula, and this one's on the front page of your formula sheet, so it's down here. This is the formula sheet you'll get given in your HSC. It's used to help you find these guys. So the plus or minus involved here is because you can find this value and then the plus answer will be this one and the minus answer will be the one further back. The discriminant is a tiny little part of the quadratic formula. That's what we're going to be working on. And when we are solving to find these guys, we have to set up our quadratic equation in this format with an equals 0. Otherwise, we can't solve it. For instance, this is actually a quadratic. If I multiply everything by x, looks like this. And if I move it across so that I have ax squared plus bx plus c equals 0, I've got it in the form that I can use for the discriminant and the quadratic formula. In this particular function, that would mean I'd find, well, this one's a, this one's b, this one's c. So I would be going negative 5 squared minus 4 by 2 by 1 equals 25 minus 8 equals 17. Now, what does that 17 mean? That's what we're doing with the discriminant. Remember, if you drew a quadratic, you could have a quadratic that doesn't touch the x-axis at all. You could have one that touches it in one spot. Sorry about my bad drawing. Or you could have one that touches it in 2 spots. Now, I've drawn all these as smiling quadratics. Of course, they could go upside down just as easily. Still have one with 2 spots, one with none, and one with a touch. And that would all be dependent on the a value in a quadratic. If it's positive, for a y equals, you're expecting one of the smiles. And if the a value is negative, we're expecting a frown. We'll do that another time. So this particular 17, if it was sitting inside of this formula, basically what we have learned is that this little guy here is 17. Now, remember I said when you run through this formula and you find the b value, you plus the root 17, divide it by 2a, and that would get us this root. And if we minus the root 17, it'd get us that root. Now, that will actually work. Root 17 is an ugly number. So what it will mean is that I will have 2 roots, but they'll be irrational. So under this interpretation, for this particular problem, yes, the roots are real. They're irrational. And they're unequal. As in, there are 2 different answers. It's one of these guys. If my discriminant, however, came out as a 16, then when I put it in this formula, I'd be expecting plus or minus root 16, and root 16 is a nice clean 4. So then I'd have my minus b on 2a plus, I'd be coming across, finding that middle value and going plus the 4 on 2a, or I'd be going minus the 4 on 2a. And because there's no ugly square roots in that, then my roots would be, there'd be 2 answers, but they'd be rational, which means no ugly bits. And of course, if I ended up with a 0 here, I wouldn't get a plus or minus. If I didn't get a plus or minus, then what I would be expecting is one of these guys, where we're stuck right on where we're just touching, because both roots are actually the same value. And we expect there to be 2 answers, but if both answers kind of come out like this, there's only one answer. So we say they're real and equal rather than saying there's one root. I don't know why. It's just one of those silly maths things. And the last possibility is if the discriminant came out as a negative value, and then I'd be trying to square root a negative. Now, if I'm trying to square root a negative, you should know by now that can't happen. You can't square to a negative, so you can't square root a negative. So therefore, that's when you're going to get these guys here that actually don't cut the x-axis. And that's all we're really doing. So here's a summary page that you might want to copy down and make your own version of, because there's a lot of vocab in this topic that you need to know in order to be able to interpret the questions you're asked and give the correct answers. For starters, when the discriminant is positive, that's when we had the 2 solutions. This is when A is negative. The pink ones are A is negative and the orange ones are A is positive, so just the smiles and frowns. The roots are what we call real, which means they exist, as opposed to when the discriminant is negative, we say the roots are imaginary, i.e. we don't have any. So that's all we can say about the roots with a negative discriminant. Up here, we could say they're unequal or they're equal, meaning they're different or it's just one root because they're the same. And when it's equal to 0, they'll always be rational because we actually lost that whole square root part of the formula. But over here, we've got a choice of rational or irrational depending on if the discriminant is a perfect square or not. Like I showed you with that 16 or the 17. If it was 16, we'd be real, unequal, rational. And if it was 17, we would be real, unequal, irrational. If it was 0, the roots would be real, equal, rational. And if the discriminant was -2, the roots would be imaginary. Another thing that you can use the discriminant for is when we talk about words like positive definite and negative definite. It's not exactly a roots interpretation, but we use the discriminant for it, so I've just stuck it over here. This will only occur with the discriminant being negative because a positive definite function is one where the y values are always positive. This one, negative definite, will happen when the discriminant is negative and A is also negative, meaning all the answers that come out will be negative. And that's how we find those things. So whether they're asking you to tell us what the roots are or asking us to prove that something has 2 roots or real roots or whatever, we just make use of these facts here and build a formula for the discriminant accordingly. What I'd like you to do now is have a go for yourself. If you can pause the video on this page and then try these answers, in a moment the solutions will pop up. Here are the answers. There's a couple things I just want to point out to you quickly. On a couple of them, I actually got this far and didn't even bother calculating what it was. I knew that 0 minus this number would be negative. Therefore, I jumped straight to imaginary roots. Over here, I calculated it because it was easy, calculated it. This particular one here, I got to the point of knowing it was positive because I was minusing a negative number. But then when I went to interpret it, I went, they're real, they're unequal. Oh, but I'm in the situation now where I've got to decide if they're rational or irrational. So I will have to actually calculate this, which is going to be 25 plus 4 by 2, 8 by 3, 24 equals 49. I'm glad I did that because that is actually a square number, which means I've got rational roots. And that completes it off.